So welcome my dear students. So today I am going to give the introduction to impulse. Okay, now what is impulse and how we can apply the concept of impulse for solution of numerical problems. So let us start with this. So let us say there is a ball which is being dropped from a certain height and I want to calculate what is the normal reaction offered by this ground once the impact takes place. So let us take an example. So let us say the mass of the ball that has been dropped is let us say 2 kg. 2 kg ball is being dropped and it is moving downward with a velocity of 10 meter per second once it takes the impact with the floor, and after the impact is over, so let us say the ball is coming upward in the say opposite direction, let us say with a velocity of again 10 meter per second. Okay, now assume that so there is a small amount of contact time between the ball and the surface. Let us say that time delta t I am taking at 0.01 second. Okay, let us say that there is a small time of contact between the ball and the surface. Now I want to calculate what is the acceleration of the ball because of the relation of this n number. What is that acceleration? Acceleration is nothing but the change in velocity, rate of change of velocity. So can I say that acceleration A should be equals to, so here there is a upthrust is total upward force is m minus mg divided by m is the acceleration that is in the upward direction. So for this ball which is moving upward, so n is acting upward, so mg is acting downward. So correspondingly, I can say that n minus mg into divided by m equals to our acceleration. And acceleration can also written as v final minus v initial divided by delta t number. Now what is v final? V final is the final velocity, that is 10. Initial is minus 10 divided by delta t, that is equals to 0.01 second. Okay, so it gives 20 divided by 0.01 means 2000. Okay, so acceleration is 2000 meter per second square. So you can see that how much amount of high amount of acceleration is being generated. So correspondingly, if I want to calculate the value of n, so n minus mg should be equals to 2000 multiplied by m. Now I have said that m is 2 kg, so correspondingly I am getting the value as 4000. Okay, so n becomes how much then? 4000 plus mg. Mg is 20. Okay, so it is 4020 Newton. So I can see that whenever the ball is coming in contact with the surface, the surface is offering a very large amount of force. But what is the restriction of this force? This force is acting for a very short duration of time. Time is very small. So delta t is 0.01 second. So for this particular small time, this force is acting on the, okay. So whenever this large kind of force is acting on a particular system or particle for a very short duration of time, then this force is known as the impulsive force. This force is known as the impulsive force. So I am talking about this type of force. Whenever it comes into the picture, that means I can say clearly there is a very large amount of force, but this force is acting for a very short duration of time, and that's why it's called the impulsive force. Okay. So what is the product of the force? That large amount of force acting on any object with a time interval is called the impulse. Okay. Now that a force acting on a particular particle for a time delta t, so that f dt, integration f dt, that is nothing but our impulse. Okay. So this impulse is this one. Okay. According to the Newton's second law, I know that the rate of change of momentum is nothing but the force. If I say force, that is equals to dp dt, rate of change of momentum, and that is equals to our force. So if I cross product it, so f into dt, that number gives the physical impulse. So what is that number? That is equals to dp. What is dp? Momentum change. So impulse is written as the j number. So j is what? J is the impulse. So that is nothing but p final minus p initial. P final is the final momentum. P initial is the initial momentum. If we know the initial and final momentum, then how the momentum is being changed, that is affected by the j number. Okay. So if the impulsive force is present, if any particular system has some kind of impulsive force acting on that particular system, then That means I should apply this relation which is known as the impulse momentum relation. I cannot apply the concept of conservation momentum, impulse momentum relation. So that relation has to be applied whenever the impulsive force is acting on the system. Now there is another aspect of this equation is that if I look about the average force calculation, I want to calculate what is the average force acting on the particle. So average of any quantity, if the quantity is time dependent, so I can use this formula that is F average equals to integration of F dt divided by integration dt. Now what is F dt? That is nothing but our impulse. That is the impulse force multiplied by dt, and that is equals to our delta p divided by delta t. Integration of delta t, dt is delta t. So F average into delta t, F average into delta t, that gives basically our delta p number. So if I see this delta t is equals to 1 second, if I say delta t equals to 1 second, okay. So then F average is what? Change in momentum in 1 second. I can derive this in other way. That means delta p, total change in momentum in 1 second. If I calculate, then I get the information about the average force. Okay. So in some situation, in this type of problem, you are also asked to calculate the average force. So average force acting on the particle is nothing but this one. Okay, integration f dt divided by integration dt. So you must know the how much time is acting. What is the time of acting? So how much on contact time between the particle and the surface is there? So that delta t number should be given to. So once I divide by delta t, that means I am getting the average information of the force. Okay. Now, so hence impulse is also defined as a change in momentum. Impulse is also defined as a change in momentum. It is a vector quantity. Why it is a vector quantity? Because I am writing j equals to integration f dt. Integration f dt. The impulse is certain direction because that is the direction acting, means the force is there. Okay. SI unit is Newton into second. And impulse is the area under the force versus time diagram. Why? Because it is integration f dt. Integration f dt means the area under the force diagram. If I have a diagram, force versus time, so how the time dependent force is there and that is varying. So the area under this diagram, will give the what value of impulse then. So impulse is the total area under this. So this area is nothing but integration of f dt limit t1 to t2. If I calculate this number, that gives the area value. So once I calculate the area number, that means it gives our information about the impulse force acting between the time interval t1 to t2. Now, if the impulse is acting along the same direction as that of the initial momentum, so let us say the ball is there whose mass is m, so it is moving with the velocity of u. So I can say that initial momentum equals to m into u. If I apply the initial momentum, if I apply the impulse along the same direction, along the direction of the initial momentum, so that means it will increase the speed. So ultimately u will increase and ultimately becomes the p final, that is equals to m into v. Okay. So in this situation, what is the J naught number? J naught is the applied impulse on this particular system. That should be equal to final momentum, P final minus P initial. That means equal to M into V minus U number. So idea is that if I apply the J in the same direction as that the initial momentum, so that means it is going to increase the final momentum. That means the speed will increase. Now in the opposite sense, if I apply the same impulse in the opposite direction, let us say initially the particle moving with the velocity of m into u, initial momentum is m into u. I have applied impulse in the opposite direction. So in that situation, what happens? The velocity will reduce. So u will going to reduce. So that means the final momentum has to reduce. So p final should be equal to m into v. Okay. Now since it is a vector quantity, so I should use the proper notation over here. So impulse is acting over here is minus j. Why? Because I am taking this side as the positive. Okay, so minus j naught is the impulse, so that should be equal to final momentum minus initial momentum. So mv minus m. Okay, or I can say j naught should be equal to mu by mv, mu minus mv. It clearly says that the final velocity v is less than u. Okay, so in other way, if I apply the impulse in some angular direction, let us say there is a ball. I have applied impulse in this angular direction. Let us say I applied G naught in this direction. So G naught has two components then. G naught has two components. One is G naught x. Let us say G naught x. And in the vertical direction G naught y. So that means G naught y. That means now this J naught x will change the momentum along the x direction. Similarly, J naught y is responsible to change the momentum along the y direction. Okay. So along both the direction, you have to apply the impulse momentum relation to get the idea of what is the final relation. If the velocity initially, let us say initially the particle is moving in this direction. In this direction, the U velocity, inward velocity. So that means only the initial momentum along the x direction is there. So there is no initial momentum along the y direction. But once I apply the J naught with some angle, that means it has two components, J naught x and J naught y. So J naught y is going to change the velocity or the momentum along the y direction. So if I say the J naught y number, what is the J naught y? That should be equal to final momentum along the y direction. So final momentum is what? Let us say a into v. The minus initial momentum along the y direction, that is 0. Okay. So from that, what you can say that v is the, let us say, the final velocity along the y direction. So v should be equal to how much? G naught y by m. I can calculate that number. Similarly, if I say the v prime is the velocity final along the x direction, so for that x component, what you can write? J naught x should be equal to m into v prime minus m into u naught. Final momentum minus initial momentum. So from that, I can calculate the value of v prime. So once I know the v prime and v, that means I can get the value of, once I know the value of v and v prime, that means I can get the information about the net resultant velocity. So that should be equals to v, let us say v double prime. That should be equals to under root of v square plus v prime square. So in this way, I can calculate the velocity whenever I am applying the impulse in angular direction. Hope you understand this. So this will give the entire concept of the impulse momentum relation. And in the next class, I will see how to apply this concept to solve some of the interesting and challenging numerical problems. So first of all, you have to understand on which particular section you have to say the force is impulsive. Not all the forces are impulsive in nature. Some forces are going to be impulsive in nature. You have to understand that which force is impulsive in nature, and that means along that particular direction in which the impulse is being applied, so along that direction you cannot apply the conservation moment. Hope you understand this. Thanks for watching my video. If you like it, please subscribe my channel.